In this video, we're going to introduce our section on radical equations and inequalities. So we're going to look at solving radical equations in this video. We'll actually break this objective up into two videos for time purposes. And when solving radical equations, we're going to want to try our best to isolate the radical on one side of the equation, if at all possible. Then we can raise both sides to the power that is the root of the radical. And that's a reason for that is because of the properties of exponents, where if we have we were to write the radical in exponential form as a rational exponent, if we raise both sides to whatever the denominator is, whatever the root is, it'll get rid of the radicals completely. It'll get rid of that rational exponent and just be an integer exponent. However, sometimes when raising both sides to a power of an equation, we end up with extraneous solutions. Solutions that we get that if we plug them back into the original problem, they don't make the original problem true, and we have to ignore those. So example 1, solve each. Remember to check for extraneous solutions. We have the square root of 5x plus 1 equals 4. So the root that we have is the square root, so we want to raise both sides to the second power to get rid of the square root. Now on the left-hand side, when we square root 5x plus 1 and then square that, we just get 5x plus 1. And on the right-hand side, we get 16. So we have 5x plus 1 equals 16. And subtract 1 and divide by 5, we get x equals 3. Now, if we check that, we can plug it into the original problem and see, is the square root of 5 times 3 plus 1 equal to 4? Yeah, because we get the square root of 16, which equals 4. We could also graph the original problem, square root of 5x plus 1, and then graph y equals 4, and see that they intersect at x equals 3. That would also work. Part B, the square root of 8 minus x and then plus 7 outside the square root equals 10. So our square root's not by itself on the left. It has this plus 7 we want to get out of there. So we'll subtract 7 from both sides. And we'll get the square root of 8 minus x equals 3. Now we can square both sides and get square root of 8 minus x. When we square that, it's just 8 minus x. And then 3 squared is 9. So we have 8 minus x equals 9. Subtracting 8 from both sides and dividing by negative 1 for the negative that's in front of the x, we get x is negative 1. So 9 minus 8 is 1. And then negative x equals 1. Divide both sides by negative 1. We get x is negative 1. And we can check that again. If we plug it into the original problem, is the square root of 8 minus negative 1 and then plus 7 afterwards, is that equal to 10? Yes, it is. We get square root of 9, which is 3, and 3 plus 7 does give us 10. All right, part C, we have the cube root of x minus 10 equals 3. This time we're taking the cube root of the left side. So instead of raising both sides to the second power, we're going to raise both sides to the third power. And when we do that, we'll get x minus 10 inside the cube root. When we cube it, just gives us the x minus 10. And then 3 to the third power is 27. So then add 10 to both sides, we get x is 37. And if we check that, 37 minus 10 is 27, and the cube root of 27 does give us 3, so it works out. All right, that about does it for this video. Thank you for watching. I'll see you next time.